Hello everyone. So in the previous video we have talked about recursion, and in today's video we are going to take one more example to make you guys more clear on recursion and how does it works. So like firstly we would like to relate this example with the help of function, then we can shift towards the recursion. So basically what we are doing is we are calculating the factorial of a given number. So here we have the function, that is the function name factorial iterative, and here we are passing the parameter as n. So the value of n we are sending from here, that is 5. So basically what we are doing is we are using some variable, that is fact, and we are assigning the value as 1. As I've said you guys in the previous video, that whenever you are working with something called addition, try to initialize the default value as 0, and whenever you are working with something called multiplication, make sure that you initialize the variable with 1. So with that, we are using the for loop over here, and we are iterating from I is equal to 2 to we are checking the condition that I is less than equal to n. So in this case, we have 5 as the value of n. So I is less than equal to 5, and we are incrementing the value, and we are just calculating the fact in this variable. So let me take a deep dive into that, by the way. So in this, we are starting from I is equal to 2. By the way, you guys can start from I is equal to 1, but there's no means to multiply 1 with 1. We would be getting the same thing. You all guys know the same. Now, so that's why we would like to start with 2, and we would be checking that 2 is less than equal to 5. Yeah, it is. So what we are doing is we are going to calculate fact is equal to fact into I. That is, now we do have 1 in the fact. So 1 into I, that is 2, by the way. Now we are incrementing the value from 2 to 3 by the help of I plus plus. Now we have the value of I as 3, so 3 is less than equal to 5. Yeah, it is. Then again, once again, we are going to do fact into I, that is 2 we do already have in the fact, and we have 3, so 2 into 3, that becomes 6. So we are going to store the 6 in the fact. Now then we are going to increment the value of I once again, then it's I plus plus. It would be incrementing the value to 4. So we would be checking the condition that 4 is less than equal to 5. Yeah, it is. So in this we are doing fact into I, that is we have fact in the fact we have 6. So 6 into 4, that becomes 24. So we can add 24 over here. Then again we are incrementing the value of I as I plus plus, it becomes 5. Then we check 5 less than equal to 5. No, 5 is not less than, but it equals to 5. So yeah, that's a true condition. Fact is equal to fact into I, that is 24 into 5. So we would be getting something called 120 out of here, guys. So that's the last value we are going to store in the fact, because after this, when we do I plus plus, it goes 6. The value of I goes 6. So 6 is less than equal to 5. No, that's not a condition. We would be we can exit the loop, and we can just simply return the fact variable over here. So that is 120. At last we are storing 120 over here, and then after we are just simply calling the function, that is we are just like basically previously you guys have seen this one. So like factorial of iterative, we are passing 5 over here, and we are doing nothing. We are just doing console.log, and we are just writing some simple words or simple text over here, like factorial using function, and we would be getting something called 120 out of here, because here we are sending 5. You guys can play along with that, give 7, 6, whatever you want to do, but that's the basic story. And now let's work on the recursion side. So basically we have the function over here, that is factorial recursive, and in this we are passing parameter as n, and in this we are sending the value of n as 5, like as we did for the previous one, but it's for the function. Now in this, as I have said, whenever you are working with recursion, make sure we need to have some base condition over here, because if you do not give any base condition, it would just stuck in an infinite loop, and you won't get anything as an output of that. So just make sure that you give the base condition. Now in this we are passing 5 over here. It's checking that if n is equal to 0. So initially we have the value of n as 5. So 5 is equal to 0. No, it is not. So just go on the else part, that is return n into factorial recursive of n minus 1. And we are calling the same function within the function itself. And we are having something called base condition. This is something called recursion, and this is something that we are doing over here. It's called recursive call. So what we are doing, guys, over here is let me give a more bit clear introduction on this one. I mean, so in this, by default, initially we have something called the value of n is 5. So we have something called 5 into factorial recursive of 5 that we do have over here, by the way. But once we are checking the condition for the first one, that the 5 n is equal to 5, we are going on this one and we are doing 5 into factorial recursive of n minus 1, that is 5 minus 1, so it becomes 4. So it again makes the recursive call to the main function, that is our function, and we are again checking if n is equal to 0, that is 4 is equals to 0. No, it is not. Then go again to the else case, and in this case we have the value of n as 4, guys. You can see, because in this case we have decreased the value of n minus 1, I mean the value of n to n minus 1, and that's how the recursion works. So now in this case we have the value of let me comment this out. We have the value over here, that is 4 into factorial recursive of 3, because 4 minus 1, that becomes 3. In the same sense, it goes over here and it checks 3 is equal to 0. No, it is not. Then again we are doing 3 into factorial recursive of 3 minus 1, that is 2. So let's write this once again. That is 3 into factorial recursive of 2, because 3 minus 1, that becomes 2. Then again we are just simply checking this one and it goes in the same sense, guys. We would be writing 2 over here, and it becomes 1, guys. Now in this case, when we are working with 2, that like when the value of n is equal to 2, so that's the case of 2 into 2 minus 1, that becomes the factorial recursive of 1. Now we need to calculate the factorial recursive of 1, that is we need the value of n becomes 1. We can check over here if n is equal to 0, or you can just simply return when we get the case of 1, because the factorial of 0 also is also 1, and the factorial of 1 is also 1. But I would like to go with 0, because if we do just simply return 1 from here, we don't be taking the consideration for the case of 0. Like, let's suppose we have passed something called factorial of 0, so we won't be getting anything out of that. So to tackle this, I would like to go with 0, or you guys can add some additional things what you want to do. So in this case, we do have something called 1 into factorial recursive of 0, because in this case it would be 1 minus 1, that is 0. Now we are sending factorial recursive of 0 and it is checking if n is equal to 0. Yeah, it is. So it says return 1. So it would be returning 1 out of, guys, so now this factorial recursive of 0 will give us the value as 1. So now from here what we can do is, we are getting the factorial recursive value of 0 equals to 1. So what we can do is we can substitute the value in all those, like this is how the recursion works, and we get like 5 into 4 into 3 into 2 into 1, and at the end it becomes, sorry, I need to add 2 into 1, and at the end it becomes 120. And that's how recursion works, because at the end we are like that's the base case, that if n equals to 0, that is factorial recursive of 0 equals to 1. And when we are like end up with our base case, like this would just simply return 1 from here. This would just simply return 1 from here. And now by the help of this is by the way, this is our fact of, let me make this more clear. This is the fact of 1, by the way. Yeah, this is the fact of 1. So what we are doing over here is we are returning 1 from here, because we made the base case over here. So in this we are doing 2 into factorial recursive of 1. Now we have the value of factorial recursive of 1. Make this, let me make this one. It would be much clearer to you guys. Now we have the value of factorial recursive as 1. So what we can do, 2 into 1, that we have 2 over here. In the same sense, it goes for the factorial recursive of, let me do that and I will let you know guys. Yeah, so now we are done with this. So like have a look on this one. Let me repeat that once again so it would be more clear for you guys. So now we made the base condition, that is n is equal to 0. So we are returning 1 out of here. So factorial recursive of 0, it gives us 1. So now we are going to the factorial recursive of 1 and we are calculating this one. So that is 1 into factorial recursive of 0, that is 1. So the value calculated over here, it becomes 1. In the same sense, the factorial recursive of 2 is equal to 2 into factorial recursive of 1, that is 1 over here. So 2 into 1, it becomes 2. Now here we need to calculate the factorial recursive of 3, that is 3 into factorial recursive of 2, that is factorial recursive of 2. We are getting 2 over here, so we can do 2 into 3, that becomes 6. Now in the same sense, factorial recursive of 4 is equal to 4 into factorial recursive of 3, that is the factorial recursive of 3. We do get 6 out of here, so we can do something called 6 into 4, that becomes 24 by the way. And at last we do have factorial recursive of 5, so we are doing 5 into factorial recursive of 4. So the factorial recursive of 4 is 24, so we are doing something called 5 into 24, that becomes 120. And at the last, like, we are returning 120 out of that guys. So it goes in this sense, 5 into 4 into 3 into 2 into 1 by the way. And like when we are working with recursion, we store this in stack, so it goes in this approach. So now we can just simply check the output and what we are getting as output over here. So let's compile this one and let's run this one by the way, recursion.js, and you guys can see factorial using function, that is this one, the using the function one, and factorial using recursion, we do get 120, that is using recursion. So in both of the cases we do get the same answers, but as I've said, like when you are working with recursion, you may feel like this is a kind of situation, it's being too complicated. But trust me, when you work with this one, when you do practice a lot of questions on this, it becomes much more easier, because like you can just you just have to write with less line of code by the way in recursion, as you can see over the function. So that's the whole story between function and recursion by the way.